Bismillahirrahmanirrahim, and hi, this is the presentation of the mini project of modern control system. The title of our project is Helicopter Dynamics Control System. The group members is Muhammad Amirul Hisham bin Muhammad Sabri, Muhammad Izhar bin Ramli, Muhammad Nasrullah bin Hamizul, and Waizakwan bin Ibrahim. The introduction of this mini project is Helicopter Dynamics Control System is the system that easy to control the helicopter system. To increase or decrease overall lift requires that the control alter the angle of attack for all blades collectively by equal amounts at the same time, resulting in ascent, descent, acceleration, and deceleration. In the system, we need to plot of the helicopter dynamics and need to determine the gain and phase of the system to solve the problem. The objective of this mini project is to get accurate and correct body plot of the system by using body plot. Measuring dynamics of helicopters' radars is very challenging due to wiring and data transmission problems. To determine gain and phase margin of the system by using body plot.
Bismillahirrahmanirrahim. My name is Muhammad Izhar Ramli. I will explain about body plot from gain margin and phase margin. This is the command for the Skillet software. The first equation asks we to determine the gain and phase margin of the given equation. The equation given GS 50 over S times with 0.2 S plus 1. For the Skillet code, startup execution, loading initial environment. This is initial S equal to %S semicolon. Numerator equal to 50. For the numerator is 50 semicolon. Denominator S times with 0.2 S plus 1. TF equal to numerator over denominator. TF equal to syslin C TF semicolon. Phase margin GCF equal to P underscore margin TF. This is the value GCF 2.4543545. For phase margin PM 17.964236. So after that we will show margins. So this is the margin we get from the code. This is the margin and phase margin from the previous command that we use in this Skillet. So we get the curve of the both graph for the phase and the magnitude. In this figure 2, we can see we have the angle. We get this angle from, we can see the previous result show the phase margin is 17.94. This is from the Skillet that we get just now from this. So the question 2 asks to design compensator lead or lag phase margin greater than 48 degree. So we assume that we add 5 the safe phase we add, so we get 53 degree. So from the 53 degree frequency phase equal to negative 180 degree plus 53 degree equal to negative 127 degree. So we will make a lag compensator. So from this negative 127 degree, we first we check at phase degree. So we add negative 127. We must make sure that we have the sensitive result. So we should put the correct number of the degree. So we choose a negative 127 degree and we get the Hertz frequency 0.5987. From this Hertz we take this and put to the magnitude graph plot. So we make a length, so we will decrease the number of hertz 0.5928. So we will round it, it will be 0.59 to calculate in this next calculation. So that's from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Hisham bin Muhammad Sabri. Okay, from the previous slide, the phase graph at negative 1 to 7, we get the gain crossover frequency equal to 0.59 Hz. So we change to the radian, we get 3.71 radian per second. From magnitude graph at 0.59 to 7 Hz, we get 20.6 dB. After that, we find the alpha. The reduction of gain is 20 log alpha. To find alpha, 20.64 we get from this. So we get alpha equal to 10.76. To find z, we put 1 decade and we get z 0.371. From z, we can find tau. Tau equal to 1 over z. Tau equal to 2.695. So we can get new transfer function using this formula. 1 plus tau s equal over 1 plus alpha tau s, we get 1 plus 2.695s over 1 plus 28.998s.
Assalamualaikum warahmatullahi wabarakatuh. My name is Waizak Kwame Ibrahim, and I will continue the presentation about the LED compensator design. From the previous slide, we have get the new transformation function, which is we get a phase LED network transfer function. And from the calculation, we use the skylight to convert the phase margin greater than 48 degree. So the result for the skylight that we get, phase margin is 48.06. So from this, we have the phase margin is greater than 48 degree. That's all. Thank you.